Hello guys, today we see another array problem, trapping rainwater. This is the most important problem and it is asked mostly all companies. Yeah, let's start. Here we can see this is given an array which is contain value 30104002 means the first one contain three building, the second contain zero building, then next contain one number of building, and next contain zero number of building, and next contain four number of building, next contain zero number of building, and next contain two number of building. If we see here, uh, 3 is the maximum from the left, and here 4 is the maximum from the right, and in between these two we can store the water. If we see, uh, we can store water in a closed container. So this is the left one, this is the right one. In between these two uh, we can store the water as it is closed. And if we try to store in above this building one means this one, then here we can see there are no support from left. So if we store above this building, then it's overflow to the left. So we can store the water this. So let's start it. Here we can use the optimized approach, and here using few steps we solve this. First, what we do, we check the left max, similarly check the right max, and in between these two we check the minimum one. In that minimum we can store the water. So let's start. First, what we do, first we find the array length of the array. So int n is equal to array dot length. Similarly, what we do, as we know, here we first we find the left max and left min, right max. So for that, int uh, int left max is equal to new int n. Here n is the length of the array. Means we create one array which contain the same length. Similarly, int right max is equal to new int, and here we pass the length of the arrays. And what we do, here we initialize an result, and we store the water and pass, so int result is equal to 0. Now what we do, here we use three steps. First one is step 1, find left max. Step 2, find a right max. And step 3, what we do, find the minimum of both. Find minimum of both left and right max. So let's start from the left one. What we do, first we initialize that left max array. So for that, what we do, we write L max of 0, and we should go from left max means we go from left side to right, and the right max is we go from right to left, because we need to find the maximum one. So max 0 is left max 0 is equal to array of 0. Why we take here 0? Because we need to find the left maximum, so we go from index 0. Now we iterate for loop and go from I is equal to 1, I less than n minus 1, I plus plus, and here you see we go from first index, not from zeroth index, and we go till n minus 1 index, not n index, because we need one closed building. In between that, we store the water like a closed container. So here left max of I is equal to, what we do, we find the maximum one. So for that we write math dot max, and here what we do, we pass the array of I if we see if the current element or the left max of I minus 1 means the previous one. If we see this one current element or previous of the left max is in between these two, which one is a greater maximum, we can store in the left max. Similarly, we write for right max. Here what we do, we go from right to left. So we go from end of the array. So array of n minus 1 is equal to array of n minus 1. And here we iterate the for loop for int I is equal to, here we go from first index. So similarly, here we go from last index minus 1 means n minus 1 minus 1 means n minus 2. N minus 2 and I greater than equal to 0. I minus minus, what we do here? Here right max is equal to math dot max, and here we also check array of I means current index minus array of I plus 1. So we write here array of I. Array means here is the R max means right max of I plus 1. And here what we do, we go for step 3. In step 3 we iterate for loop I int I is equal to 1, I less than n minus 1, I plus plus, and here whatever we got the minimum we store in the result is equal to result is equal to uh, math dot mean, and here we pass the left max and the right max. So left max of I comma right max of I, and simply minus the array of I. Why we minus here array of I? Because if we see some of the places there some building is present. So if there is a array of I means it is the building contains 0, then no need to reduce the uh, building. So here we can see it is contain one building. So we reduce this one. Now in last we simply return the result. Let's run this. Let's see. Here it is showing incompatible. Okay. Right max math dot max. Okay. Line number 17. Math dot max array of, okay, for let's see, for int I is equal to n minus 2. Okay. I greater than equal to 0. Okay. I minus minus, then right max is equal to math dot max of array of I of, okay, here it is missing of I because it is an array. So later on it again it is showing minimum 1. Okay. result plus equal to math dot means left max right max minus array of I. Cannot we find the symbol? Result math dot mean left max. Let's see whether it is exact same or not. Left max, okay. Okay, here you can see it is not same. So correct this. Let's run again. Here you can see it is running successful. Let's submit this. Here you can see all the test cases pass and working as expected. That's all. Thank you.